Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one very important process of analog to digital conversion, which is called delta modulation. Now, we already discussed a detailed conversion of analog signal into digital signal with the help of sampling and quantization, and this is what we exactly do in pulse code modulation system. So in PCM system, we basically carry out sampling and quantization, and that's how we achieve the conversion from analog to digital signal. Now, however, there is one more way in which I can convert analog signal to digital signal, which is using delta modulation. So let's try to understand what exactly happens in delta modulation. So I'll make one important statement which defines the process of delta modulation. In this process, we simply sample the modulating signal first. Sampling is must in conversion to digital signal. But instead of quantizing the sampled signal, all we are going to do is we will compare the current sample with the previous sample. If the current sample is greater than the previous sample, then we transmit logic 1. And if the current sample is less than the previous sample, that means if the signal is decreasing, we transmit logic 0. So this is all we have to do. We have to keep on comparing the current state of the signal with its previous state. So in simple words, if the signal is, let's say, increasing, in that case, every current sample will be greater than the previous sample. So we will keep on transmitting logic 1 in such a case. On the other hand, if let's say signal is suddenly decreasing, then every current sample will be less than the previous sample. In that case, we will keep on transmitting logic 0 and so on. So whenever signal increases, transmit logic 1, signal decreases, transmit logic 0. We receive this 1 and 0 on the receiver side. When you receive 1 every time, you understand that you have to increase the recovered signal. So you increase the signal by a fixed step size for every logic 1, you decrease the signal for every logic 0, and that's how we recover the original signal on the receiver side. So let's discuss delta modulation block diagram. In the block diagram, we have op-amp connected in open loop configuration. It acts as a comparator because we want to compare the current state with the previous state. M of t is my modulating signal which needs to be converted to the digital signal. It is passed through sample and hold because whatever is the output of comparator, I don't want that output of comparator to change in one clock period. Because my input signals will keep on changing continuously, they are analog signals, I want to preserve the output of the op-amp for at least one clock period, and that's the reason we have sample and hold. So on every clock cycle, one value of output of the op-amp will be taken and given to the output side. SOT will be the digital signal. We know that when acts as a comparator, op-amp will generate any of the two output levels, plus Vset or minus Vset. Plus Vset will be taken as logic 1, minus Vset will be taken as logic 0, and that's how my output signal will be digital in nature. Now I'm taking that same digital signal in the form of 1s and 0s and giving it to a counter. Every time logic 1 is generated, it means the counter will count in upward direction. You can see it's an up and down counter. So that means if SOT is equal to logic 1, then counter counts in up direction, and if SOT is equal to logic 0, then counter counts in down direction. The clock is continuously provided to the counter. Output of the counter, which is a digital value, is given to digital to analog converter. Output of the digital to analog converter will be nothing but the signal m cap t, which is compared with m of t. So what kind of signal we will get at the output of DAC? Let's say, for example, logic 1 enters into the up and down counter. Logic 1 means counter will count in upward directions. If there are, let's say, 4 continuous logic 1, then counter will count in upward direction and output of DAC will increase by a fixed step size 4 times. Now let's say there are 4 zeros appearing at the output side. So for every logic 0, counter will count in downward direction. So this time output of digital to analog converter will reduce 4 times. So output of DAC will be a step-like signal which we are calling m cap t, and it will be compared with m of t.